Okay, let's start. So the exam is Wednesday. I emailed everybody a sample problem. I'll go over that later in the class. So So let me go through my solution for the homework. Hopefully at this point, you guys are getting better at breaking down these problems. I'll talk about functions in a minute and breaking it down into functions. I was thinking about that over the weekend. But let me go through again my solution and the way I went about attacking this particular problem. So again, I'm going to have in the main function what I think is going to be the outline of the solution, and in my breakdown of it, that I was going to, and I will upload this. Actually, we're going to work on my solution in class afterwards. So I would just don't type it in because you're going to be downloading it. So first thing is to find out the number of games, and so I probably should have written a function to do this. Typically when you're doing the input, it should be relegated to a function. I didn't for this particular problem, probably a mistake, obviously not fatal. So I'm going to prompt the user for the number of games. I'm not validating it. And now what I want to do is, since there are going to be a number of games, I'm going to want to play the games, play each game. And my idea was, why don't I just write a routine that's going to play the games? And so I'm going to have some function that it's going to play the game. And the game is going to return a result about how much money you won. I'm going to want to keep track of the total amount of money that you won. So I think what I want to do is I'm going to have a variable called winnings, and I'm going to be constantly updating winnings by how much you won on a particular game. And I said, okay, fine, I got that. And if I have a variable winnings, I'm going to have to initialize it to 0. And then to play all the games, my preferred method of repeating statements is to use the for statement. And I want to repeat the playing of the games, the number of games that the person has indicated. So my thinking was, okay, get the number of games, and then just have a function that is going to play the game. That is going to return the amount of money you won, and I'm just going to have a running total that's going to add up into the variable winnings, how much you won for the playing of each iteration of the game. And then ultimately, after that happens, I could have a function, or since it's just one line, I'm going to print out
Professor?
Yeah.
For a number of games, wouldn't it be better to just have it range num games? Because then that range would just start at 1. And then it would be like, if you wanted 3 games, it'd be like 1, 2, 3.
Say again.
So wouldn't it be better to have just range and then num games inside the parameter for it?
Instead of 0?
Yeah.
So now it's going to go from 1 to num games?
Yeah.
I didn't teach that. So I think you're right. as opposed to starting it at 1.
Because it would give somebody a game extra.
This won't,
It won't? Oh, okay, just starting from 0 won't? Okay.
because remember, this is going to go from 0 to num games minus 1.
Oh, yeah, like
Yeah.
index, yeah. My
Yeah,
bad.
it works like the index. So, but yours would be better, you don't have to, I guess, be annoyed by starting at 0, but in this particular case, I'm sort of used to it, so,
Okay, that's fine.
but. So then I'm going to print out the number, your total for the number of games is how much money you won. So now I sort of have the outline of what I want to do, and now I'm going to define winnings. And then in winnings, okay, so the logic here was fairly complicated. So the first thing we're going to do to strike down, not winnings, it's going to be play game. And so the first thing I'm going to want to do is the person's going to make a guess. And so again, maybe I should have broken this down into having a separate function. Actually, I should have had to have the guess. So here, and I suspect many people did it this way. So they could enter a guess. Yeah, I should have had this as a function, but I didn't. Okay, this will be a good talking point. So now I need to validate that this is a valid guess, where a valid guess is in the range of 1 to 99. So there are a variety of ways to test for the validation of this. This one is I like because it seems so I'm guessing if the guess is not in the range of 1 to 100, where remember the range is going to go back 1, so it's going to be 1 to 99. So if this is false, so if it's in 1 to 99, and if I do a not in 1 to 99, then I'm testing for the validity of the guess being in the range of 1 to 99. And then I could say print error invalid input, and then I would just simply reprompt them for the value. Any other ways you guys tested for the validation here? Not everybody did it this way. Another way is another way to do this, the equivalent is if guess is less than 1 or if guess is greater than 99. That's another way to test. If either one of those is true, it means it's an invalid guess. And a shorthand way in Python that is sort of nice is that if you can say if not one less than or equal to guess, so another way to do it in Python is you can actually not have to have, you can have this sort of mathematical notation to say that guess is in the range inclusive of 1 to 99 by doing it this way. And so you do this test, but because we're testing to see if it's not in that range, we prefix the test with word not. They're all equivalent. Whatever you're most comfortable with, whatever makes most sense to you is fine in terms of testing that a value is within the right range. But again, I think this should have probably been in a function. So now that we've got a guess, it's okay. Now what we want to do is we want to spin the wheel. And because I'm going to be spinning the wheel multiple times, one when the person makes their initial guess, and possibly a second time if the value is within plus or minus 10, I decided to create a spin function, the spin wheel function, which is going to spin the wheel and return for me what the spin was. So I know that this code to spin the wheel wasn't particularly difficult. You just use random and print out the value. I still said I'm going to write that as a function. And now that I've spun the wheel, now I want to see if the guess is equal to what they spun. And if it is, it means they got the right number. And now they're going to get either $2,500 or they're going to get the guess times 50, whichever is larger. So I simply, the most straightforward way I can think of doing it is multiply the guess times 50 and see if that's greater than 2,500. And if that is, then I'm going to set this variable called result, and I'm going to set that equal to guess times 50. And result is what's going to be the value that I'm going to return. If the guess is times 50 is not greater than 2,500, then the rule says that you get $2,500, and so I'm going to simply set the variable result equal to 2,500. Oftentimes, when you're writing a function, you have a variable, you can give it any name, that is going to contain the result that you're going to return, and you simply, in various parts of the function, set that variable to a value, and then your last statement in the program is going to be return result, or whatever that variable is. So I'm testing to see if they made the right guess. If they did, then I'm figuring out which of the winnings they get, either 2,500 or guess times 50. Any comments on that? That's I think there was a max function I could have used, but I sort of did it the old-fashioned way, just using an if statement. Now note that after I've done if the guess is correct, and I had this if statement, notice now that I indented back to else. The else lines up under if, because this is going to be the else clause where the guess was not equal to the spin. And so now what I need to do is to see if the spin was in 10, plus or minus 10. So I'm going to set up a variable called diff that is going to be equal to the guess minus the spin. And now I want to see if that guess was within 10. So I'm going to test to see if the diff was greater than or equal to minus 10 and diff was less than or equal to 10. So this is a way of testing to see if diff is in the range of 10. I'm trying to see if this in fact is true. If this in fact is true, then they've won another way of winning. So I could have expressed this in a variety of different ways. I don't know if you guys did it. You could have taken the absolute value of diff and checked to see if it was less than 10. Anybody do that? Nick, you had a different way?
Yeah. So I made two empty lists at the top of the function. And then I had, like for I in range, and it went from spin to spin plus 11. It would append each number from the...
And you check to see if it's in the list?
Yeah, and I did the same thing for the like minus 11.
So effectively, Nick created a list. He didn't type all this in because he's averse to typing. He wrote a for loop, but he typed in, right, you did this. you effectively had this list that went this isn't going to work, this code, but effectively what he did is he created this list with these values, and he created a list with but he had code that did this, and then he checked to see if the value was not in that either of those two lists, and if it was, you won. Okay, you can do it with a list. That's a little more drawn out. You could have just done the arithmetic, it seems. You agree?
I'm not sure this one was pretty effective.
I'll take that as a no. He doesn't agree. Okay, fine. No accounting for taste. Surya, you had a question?
I did it kind of similar, but I didn't make a new variable. Instead, I just did guess minus 10 is less than or equal to spin is less than or equal to guess plus 10.
So you just did this twice. You put that here and here.
Yeah.
That's fine. I think if you recall, there's an absolute value. Remember, there's an absolute value function. So if you did absolute value of this, then all you would have had to test for to see if diff was less than 10. Because it would never be a negative value, right? And so if it's between 0 and 10, then they got it right. So this is probably the most efficient way, but so what? Okay, so now that we've established that we got that they have the number within plus or minus 10, now we're going to ask them they want to spin the wheel for a prize. And when they're going to put in a Y or an N, we'll put that in the variable A and S. And because they might not follow instructions, they might type in a capital Y or a capital N, I will ensure that the result is in lowercase by using the lower function, lower method. And now to ensure that they actually typed in a Y or an N, I'm going to check to see if Y or N, if it's not equal to a Y, and it's not equal to an N, it means they typed in an invalid value. So and then reprompt them. Okay, so I know that when I get out of this, I probably have I have an answer that is Y or an N. And again, I probably should have relegated this to a function so the code doesn't get cluttered up with this. So now I'm going to come out of this, and if the answer, which I know has to be equal to either a Y or an N, if it's equal to a Y, then the problem said, okay, spin the wheel and then give them the result times 20. So I could have said spin is equal to, and remember I wrote the function spin wheel. I haven't implemented it yet, but I know that I will. Spin wheel, and then I'm going to say result is equal to spin times 20. And I didn't have to create the variable spin. I could have just said result is equal to spin wheel times 20. Otherwise, the rule said that they get $750. So note here that I'm in various parts of the program, I'm updating the variable result, and that's what I'm going to return. So I think I've done all the work here. I haven't written spin wheel yet, but I've figured out how much they won or not. Well, I didn't actually figure out if they won or not. How do I know if they won or not? Well, so they can come in here, they can make a guess, and if the guess is equal to spin, fine, then result will have a value. If it's not equal to guess, then they come in here and we see if the result was within plus or minus 10, and if it is, then result is going to get a value. But how do I know if they didn't guess the number correctly from the get-go, or if it wasn't within plus or minus 10? Well, one side effect of doing all this logic is that the variable result will, by the time I get to down here, will have a value if they won, because I'm setting it to a value here and here and here and here, all the endpoints of that. So what I could possibly do is if the result is equal to 0, well, if the result is greater than 0, then I know they won something, and so I can say print you win that much money. You won the right. You won that. If it's not greater than 0, it means they didn't win anything, and so I'm going to say print you lose. And the only thing I have to tidy up here is that since I'm testing result, and result is set when they win, but it's not set when they didn't win, then the first thing I want to do in my program is to actually set the variable result, initialize the variable result to 0. So by setting result to 0, I ensure that result is either going to be 0 or greater than 0, and therefore this test won't fail. And then finally, I'm going to return result, because that's the whole point of this. We're going to calculate what they won or didn't win and store it in result, and so that value will then be returned when I call play game. So result will be returned from when I play game, and it'll either be a number or 0, and I'll be adding it to winnings, and so my winnings is then going to increment each time I play a game, assuming I won. And that's why I need to return the result. And then finally, my only thing to tidy up is I did say I wrote a function called spin wheel, which returns a value, and spin wheel generates a spin, and it's equal to random.randint, and this can be between 1 and 99, and I'm going to print out so I'll print out what happened, and I'll return, because it's a function and most times we're returning a value, I'm going to return spin. And since I'm using the rand function, I need to make sure that I specify import random, the random module, so that Python knows where to get randint. Okay. Any questions on this? Let me I did this before. So once you go to Blackboard and go to the content section, and once you go to lecture 20 and download homework 18-1V2. That's the code that I wrote. So and then once you download it, I want you to take that code, hopefully you understood it, and I'm going to want you to now add to it to change it in two ways. First, and I'm just wanting to get you practice for functions. For the first one, why don't you change the program so that instead of me prompting the user for the number of games in the main function, why don't you break that out and make that a separate function? And just make sure so do some validation to make sure that the number entered, is it ensure? It's ensure, I didn't know that. Ensure that the number of games is greater than 0. So take the program and change it so that you call a function and it prompts the user for the number of games and ensures it's greater than 0. And then, because in every game there could be 2 spins, make sure that in the second spin that if by chance when you spin it a second time you generate the same number as when you generate it the first time, don't allow that. Respin the wheel to make sure that you get a number on the second spin that was different than the first one. Okay? So when you started the game off and the random number generator spin gave you a number of 50, and then the person guessed 45, so they're within 10, and then suppose the person said, okay, respin the wheel again for my prize for being within plus or minus 10, that when that is spun a second time, that if by some chance the random number generator generates 50, which is what it generated the first time, don't accept that and respin the wheel and generate another number, and continue to generate numbers until you generate a number different than 50. So I don't want the same number generated twice in the game. Get it? So change the program. Probably have to change the spin function to ensure that you're going to have to do a couple of things to do that. So why don't we take 10 minutes and now do both of these. Yeah.
Can this prompt be like anywhere? Like, I mean, not prompt. Can this function be anywhere within the program? Do you want at the very beginning?
It's just, you're just replacing,
Okay. What's in what? Oh,
yeah, I mean, it's really a simple, right, you're replacing this. Okay, let's see what we got here. So I'm hoping everybody can get this. So instead of prompting the user here, and additionally I wanted the validation, it would seem like instead that instead of just having the input statement here, what I really would want to do is I would want to instead let's say I have a function called getGames, which is going to return a value, and then I'm going to now define getGames, and I'm going to prompt the user for a value. I'm just going to put it in a variable, and the variable it's independent from the variable where it gets called. And now I said I want to ensure that that number was greater than 0, and so I'm going to have to do a validation test to make sure that when games is less than 1, that we now are not going to accept that. So we just do our regular validation using the do while loop, and then I'm going to return num games. So I'm going to talk in a bit about the usage of functions and where I think you should be in terms of the usage of functions. But I think at the very least, I'm assuming that everybody understands the mechanics of how to use functions, how to call them, how to define them, and how to return a value. And at the very least, in terms of getting input values, that they should be used to prompt the user for a value and do validation if required, and then return. So you can almost use this as a template. But I'm assuming that everybody gets this. If not, is that true? It seems to be a sort of straightforward use of functions. And I understand, let me preface this by saying that I understand that my bigger use, my more advanced use of functions, while I'm hoping everybody understands when I go through the code, that makes sense, that in terms of actually writing programs from scratch and doing it the way I do it is more difficult. I get that, and I'll talk about that in a minute. So let's just do the second part. So, okay, I did the first part. So how do we do the second part? Again, since we could have 2 spins of the wheel in a particular game, how do I ensure that the second spinning doesn't produce the same value as the first spinning? And if it does, spin another number. Oh, Katie. That's actually more than I wanted. That would work. But, so what did you do, Katie? Every time you spun it, you added to a list?
Yeah.
So in Play Game, let's suppose you created a game, you created a variable called spins, and made that an empty list?
Well, I just made it called list after I spun it. So after it says spin equals spin wheel, and put it down, I made like a list there, and then I did an if statement. Where am I? Oh, I said while the spin is in the list, so there's an error and spin again, and then after it, I would put it in the list. But I don't know if that's right, but I tried.
So what'd you do? Tell me what you did here. You had, after spin you said list equal,
And then just nothing. And then I said while spin is in the list. I said print error spin again. And then prompted them to spin again.
well, there's no prompt, you just got to spin it, right? So you're going to say
Right.
spin
Did the function again here.
equal spin wheel.
And then after it, like not in the while statement, I said list append and just to spin.
You did over here.
Yeah.
But then here you spun the wheel again.
Oh,
That's the second time. But you're getting warmer.
okay.
That's a good instinct, okay? But, so you, okay, so you spun the wheel again. But then here you spun the wheel again.
Oh, okay.
That's the second time. But you're getting warmer. That's a good instinct, okay? But, that's a good instinct, okay? But, so you, okay, so you spun the wheel again. That's the second time. But we didn't necessarily, the list would have worked, but we didn't need the list because all we care about is one value, right? So if they spun it here, let me kill this, and they got 50, so spin's going to be equal to 50, right? So when they're here, then we want to check to see if it's 50 again, right? Because that's the second time. The first time, because I did say that it was per game, not for all the games. So here, you would have said if, now you probably have to give this as a second variable, right? And then if you said if spin is equal to spin 2, then you'd want to spin again. And that actually is one way to do it. But, okay, so Katie, so now that you're in the game here. So here you get that. Does that make, this is where you were going, right?
Yeah.
And then you would have then say probably spin it again. So you'd say spin 2 equal spin wheel. And that would have sped it. And then you would have had to change the references here to be spin 2, right? But does everybody see that? If this actually works, it's just one change. How would you change this? Here I'm testing to see if spin 2 is equal to the original spin. And if it's not, we're going to respin it. That works, right? That's what I asked for. So you spin it up here, and you spun it, and you got some number. Let's say it's 50. Fine. Now, the second time you spin it is down here when you're in plus or minus 10. So you spin it a second time, and you put it into spin 2. And what we want to do is we want to make sure that those two spins aren't the same. If they are, you want to respin the wheel.
Did you make it into a while?
It's very good. So did you see that, Katie? You see that? The if is correct, except what if, by chance, the second time you spun it 50, right? Or the third time, rather, because here you spun it a second time and here you spun it a third time. So what you really want to do is, instead of an if you made this as a while, then you would never get out of that loop until spin was not equal to spin 2. And that's one way to do it. So, Katie, if you, your idea of doing the list would have been good if you would have, let's suppose you're playing 10 games, and suppose you said, when you spin the wheel, you should never spin it so that it was a number that was spun before, then you would do the list. That's very good. That's why I thought your instinct was good to think of it that way, but it was sort of, it was more than what was being asked for. Okay, so let me address the exam. So sort of seems Spartan. I feel like I'm cheating you. You're not going to agree with me. So the program, so the exam is Wednesday, and it's just one problem. So my fear is, I don't want to give you a problem that you could have solved in 2 hours, but I only gave you an hour and 15 minutes. That would have been unfair. And in former exams, I gave more than one problem, but I thought if you get stuck on one problem, you're not going to get to the next one, and it's really not going to be a fair test of what you know. So I've limited to one problem and broken it down into different parts so that if you get stuck on one, you should be able to do something else. Point number one. I would strongly suggest that you do on your own the problem that I gave you. So I loaded onto Blackboard a problem with my solution. It's in Lecture 20. I emailed everybody that was there. That would be a good way. That'd be one of the things I would do to prepare for the exam. I think if you could do that problem, you're probably in pretty good shape. The problem I have is a little more work than what's there, but not a ton. So let's talk about functions, because I know that I was thinking about this over the weekend, really. So I know you'd say, why is he thinking about this stuff over the weekend? But I do. My cross to bear. So I I get it. I spoke to, I get it that this notion of functions is not as natural to you as it is to me in terms of using them in programs. So number one on the exam, you will have to demonstrate to me that you at least know the mechanics of the function. So for example, by prompting the user for an input and returning a value. So you do need to understand how to set up a function, how to call it. And for sure, when you're writing this thing, you should be using, because this is not a big deal, that you should be having a main routine that gets called from the bottom. What I don't care about for the exam, and I guess for the homeworks going forward, unless I say otherwise, is if you want to dump in a ton of code in the main routine, that's fine. Because I understand that just, you have enough to just assimilate how to use all the different things that exist within Python, ifs and whiles and all the methods and functions that I've thrown at you. And it's a lot of stuff. And then to say, oh, fine, and then figure out in 75 minutes how you're going to partition this into different sections within functions. The way I seem to know so naturally do it when I'm doing the homeworks is a lot to ask. So for the exam, there will be at least one part where you're going to have to call a function, but for the solution to the main part of the program, you can just put it all in main, and I'm not going to take off points for it. And it's not just take off points for it. I don't want this to be exam driven. I think what will happen over time, however many weeks we are into the semester, isn't enough time. This isn't a reflection on you. I was the same way. But if you were to program for a year, I don't know what it is, let's say for a year, you would just naturally gravitate towards writing more functions. Because what happens is if you write some routine that's 150 lines long, right? We wrote something here that's maybe 40 lines long, and you wrote something that's 150 lines long from start to finish, and you went back to try to figure out what was wrong with it, as you do all the time now with your programs, it would be unmanageable. And by breaking something up into a function, say, yeah, I know that works, so I don't have to worry about that, and I'm just using it somewhere, you would understand as you write bigger programs the wisdom of breaking things into functions. But you're not at that stage yet, and I don't expect you to be at that stage yet. If you can construct an algorithm, a set of lines of code that give me the right solution, I'm happy and you should be happy. And the use of functions is something that would happen as you mature and you get more experience writing code. I do think introducing them to you is something I have to do, because if you were to go on and learn more about programming, it is an integral part of programming. So at least understanding what they do and how to use them is something you should know. But at this point, I'm not going to require that you use them extensively. Okay, does everybody get that? So, okay, so that's point number one on the exam and going forward. So I did give you that one, and that was a problem from a prior exam, but that was, and the reason I say that the problem I haven't finished yet, but the problem for the exam on Wednesday is probably going to be a little longer, as that was one problem, but the exam had like 2 or 3 questions on it, so the amount of code was a little shorter. But if you can do that, you should be in pretty good shape. So in terms of the components of Python that you might have to use in the program, in the solution. So you're not going to have to, and actually I'm going to limit you in terms of the solution, not going out to the internet and typing in how do I do this and coming up with something that we haven't done in class. So in terms of the functions and methods that you can use for the solution to the problem, it's going to be limited to what we taught in class, plus whatever's in that document that I gave you, which had more functions and methods that I didn't go over. So that would be the sort of the universe of things that you could use. I don't really think you're going to need to use that many things. And so I've limited, in terms of things you should know, to these particular functions, defined as a method, but I had it here ready. So the len, these are things that, hopefully these are things, the infloat, input, these are things hopefully that you are conversant in. It's not a big deal for you to use these things. You know about them. The different data types, integer, float, strings, and lists. The in operator, the numeric operations, you might have to use concatenation or use substring or elements of a list, so how you can extract an element out of a list or characters out of a string. And the methods that you need to know would be limited to these four. So we've learned many more, but I don't want you to go back and have to review a gazillion of them. In terms of printing, we learned how to use the tab stop. And if any of these things you want me to go back and review, I'm happy to do it. So if you want it, when you're printing, if you want a tab, like you're tabbing on your computer here, if you remember, if you embed in a string of \t, it tabs. Not a big deal. You can always space. And then, of course, you're obviously going to have to use if and else or if elif. And you're going to be using a while statement. For repeating statements, you're going to be either using a while and or a for statement. And I don't care which one you use. So, I remember someone in the class told me that for whatever reason they prefer using a while to even repeat statements over and over again instead of a for. If you use it on the exam, that's fine with me. And you will have to write some simple function that will, you do have to understand the notion, maybe you want me to review this, of passing a value to a function and then having that function be able to use that value and then returning a value. And then we might have to generate a random number. You should be familiar with that. You should understand how to use a while statement for validation. And this is just sort of a template of a statement for computing running totals, where you have a total and you're adding to it the result that a function returns and putting it back in the total. You might have to use that, or if you're not breaking down that part of the program where you could have a function, you probably won't need that. It won't be a function, it'll be something else that you have here. So like in the program we had today for winnings, here's an example of that. So we were having a running total. Winnings is the running total for how much you won, and you're simply taking the result from the function. It returns a value. You're adding it to winnings and putting it back into winnings. I just use that as sort of a statement that happens an awful lot when we write programs. I think. Any questions, any of these topics you want me to give you an example, just review? Of course, I'll download this, so you don't have to copy this down. This will be in the notes with today's lecture. So it's my intention that most everybody in the class, I'm hoping everybody, but typically that's not the case, but most everybody in the class should be able to complete the program within 75 minutes. How much did it, okay, so for today's homework, how long did that take? Okay.
Too long.
I would assume that 75 minutes is too long, so it's greater than 75 minutes. And where did you have, can you say where you spent the bulk of the time?
Well, I got all of it for the most part. It just kind of took me a while, and then what I kind of got stuck on was just doing the total. So that kind of took me a long time just to kind of mess around with the code I already had written.
If you didn't have to do the total, if you just print out, you mean what the total for all the games?
For all the games, yeah.
So if you just had to print out what the result was for one game, right? You played the game and you won this, you didn't.
Yeah, I think I mean, I kind of did it in different settings, but I think that 75 minutes is maybe,
For that one?
yeah.
Okay. So, so a couple points with Chris.
So I've been doing running totals with a list. It's like
Or you dump the thing into the list and you do the sum of the list?
every time there's a total or anything, I just append it to an empty list, and that works way better for me. That would not be acceptable.
Yeah, so a couple of things. So Chris's question first. So my rule for grading is if your method works in all cases, if your method doesn't introduce some limitation, it's not the one that I use, which is not something that I grade on, but then you get full marks. So if you dumped, does everybody see what Chris is doing? So for today's homework, if you played 5 games, Chris created a list, and every time he had a result, he put the result in the list, and at the end, he said, sum the list and have a nice day. So obviously, I didn't do it that day. Is it somewhat, don't take this the wrong way, wasteful? That's not the right word. Is it not as efficient as the way I did it because you're adding things to the list? Yes, but it's not a bad solution, and you could argue that at some point if you wanted to print out all the elements in the list, you have it, and so you have the ability to print out all the elements, plus you can take the sum whenever you want it.
Yeah, my thinking was also that if in the particular case you needed to get a specific...
Yeah, right, you have it there.
A specific result, you can get...
Yeah. So for sure, 100% you would get, there's no points deductions for that, because that is actually a legitimate way of doing it. It would fall apart if you're playing 1 million games, 10 million games, right? Because then you're taking 10 million elements of memory to store it, you could blow up. It's something that we don't consider in this class, but in my particular case, the way I did it, if we didn't have a requirement to save the actual scores of each one, then I just have one element. I have just one data winnings, right, you see. So, but you should do what you're comfortable with in terms of writing the code. I 100% think, Chris, that if you would do more programming and you were to do that and you become just more familiar with programming, that you would adopt what I did, because it just is it's a much more efficient and sort of natural way of doing it. But you're still new at this game, and so I'm happy that you've latched on to a way of doing things that works, and it's generalizable and work in all cases. So the problem with writing these programs is everybody has, and I suspect Katie ran into this, is you get one stinking error, and you can spend hours trying to get through that stinking error. And the error could be like so dumb, but it doesn't make any difference. You're stuck. And I don't, that's the curse of this business. You're no different than anybody else. And that's sort of my advice of, sort of walking away and looking back at it, a half hour later. That method doesn't quite work in a 75-minute exam. You say to me, I'll be back in a half an hour when my mind is clear and I'll fix this program. Unfortunately, it can't work. So I'm hoping the program is more straightforward and you don't run into that roadblock. But I understand that's part of the game here. So, I'm finally... But I'm grading on, obviously you give part credit, and so if you get something, if you have the right idea, and you don't get it running, but you have the right idea, and you're off by 1 or 2 statements, I'm going to take off points, but I'm not going to take off the majority of the points because you were close, So it's really, I do look at every line of code when I do the grading. It's just I don't take this code, it doesn't work. It gets a 40. That's not the way it works. I've got to look to see what you've actually done, because I know that you could be off by 1 stupid statement, but you have the bulk of the idea. You understand the bulk of the idea, which is what I'm trying to measure. Okay, I'm stopped being defensive about it. So. in any case, I'm not, obviously, I'm not going to do any more material for today. So I would do the practice problem. If you want to do more, go back and redo a prior problem that you hadn't done before. You know, perhaps you did poorly, you didn't do it as well, and see if you can reprogram that. And if you have any questions, just email me. Katie?
For the exam on Wednesday, is it gonna be like a problem like about like investing in future values? Because if so, like, I kind of want to review those equations. You know what I mean?
If it were, you don't have to know
Okay.
about future value.
Because I know like in the other homework examples, like when you're doing like compounding annually, like I didn't know the equation off the top of my head and I'd have to like look it up.
So okay, so two things. So I think some of the finance people here, there is a formula for doing future value, so you don't have to use a for loop.
Okay.
But if you didn't know future value, okay, and suppose I said, Katie, you have $100 and you're making 1% interest each day. I wish we were, but we're not. And I said, how much would that $100 be worth in 30 days? Where you get 1% of it, you don't need, what would you do?
What's 1% of the 100 for 30 days? And that just
You're getting it every day, though. So today, you give the bank $100, and they say we're going to give you interest of 1% per day. So how much is that $100 worth tomorrow? 101. And what is it worth 2 days from now?
102.
And a little, right? Because you're going to get interest on the 101,
Okay.
right? So really, so if you had an interest rate of 1%, 0.01, right? And you had a principal amount of $100. Stop me if I say something you don't understand. We good? So if we want to know what that's going to be worth in 30 days, what code would I write? So if it's 1 day, we said that the principal is going to be whatever the principal is today, so it's still the $100, plus each day you're going to get 1%, the rate, times the principal, right? So this was 0.01 times 100. That's what it's going to be worth tomorrow, right? So this, if I would have put numbers in here, this would have been 0.01 times 100. Right?
Right.
Now, what is it going to be? So that's after 1 day. And let me take out the 100 and insert the principal here. What is it going to be after 2 days? Well, if I took this, because now after the first one, principal is going to be 101. And now, so the next day, it's 101 times 1% of 101. Stop me. I don't see I get it, look.
Just gonna go while.
So, very good. So now you do give me the look. Okay, so now instead, you might have said for I in range 0 to 31,
And that's it.
that's it, right? Because you're just going to repeat it 30 times.
Right.
That's future value. All that the formula is that you don't have, if you knew the formula, there's just like a mathematical formula that would do that all in one statement. So you could have either done that and had sort of the long way of doing it, or you could have just plugged it into the formula to do the short way of doing it. But you should understand this.
Yeah.
It's really the same thing. Okay? Are we good?
Yeah.
Anybody else? Okay, so that's it for today, and I'll see you on Wednesday.